Alright guys, welcome back to another video, and today we'll be going over the first lesson of Unit 4, or 5 should I say, Unit 5, and this lesson is going to be on slope / rate of change. And so if you guys are wondering, the whole main idea or the main things that we're going over, which is the unit title, is going to be linear functions, and we're just going to be looking at different types of stuff relating to the linear equations. I know the last unit we was talking about just functions and all that stuff. This is going in a little more detail only into linear equations and functions. So yeah, let's go right into it. So first, right, whenever you're dealing with these types of equations, you always want to notice different things, right? You want to notice if it's a positive slope, a negative slope. So first, let me just write the title in. Slope / rate of change. So let's make this a little bit larger so you guys can really see what I'm talking about, because it's pretty small right now. Let's move this to 24. Alright, so this is our title for today, right? Slope / rate of change. So what do we mean by that, right? The slope, also known as the rate of change, also known as the average, right? That's basically if you look at a graph, the amount of rise, the amount it goes up, and then over the amount it goes down, right? So for example, this would be the slope of rate of change is rise over run. So how much it goes up, and then how much it goes to the left or right, or how much it goes down, and how much it goes left or right. So there are 4 different types of graphs, right? Regarding linear equations, there are positive slope graphs, negative slope graphs, zero slopes graphs, and undefined slope graphs. So let's take a little look into these different types of graphs and try to decipher which what you can change in the equation to make different types of these 4. So let's go to desmos. So let's start with positive slope, right? So obviously, first off, all linear functions or equations have this form, right? They have the form y equals mx plus b. So y is the y coordinate, x is the x coordinate, right? M is always the slope, guys. Always make sure to write this down. Write this down right now, okay? M is the slope of the equation. B is the y-intercept, where the graph crosses the y-axis, all right? So, for example, let's say our slope is 3, right? It rises up by 3 and goes to the right by 1. Or, yeah. 3 is the same thing as 3 over 1, right? So if you guys want, you can write in this form as a slope, so you guys know that it's rise over run. So it rises up by 3 and runs 1. And so you guys are wondering, what are you talking about? 3? So basically, if you look at this graph over here, right, you go by 3 coordinates. Each is a coordinate. And let's just, so we can actually see the graph, let's make our y-intercept, or the area it crosses the y-axis, let's make it -2. Alright, so we can clearly see the graph right now. So we know, so let's take a look at the slope, right? We know it's rising by 3. So it goes up by 3, right? It goes all the way up to 1, which is right over here, right? Let me just zoom in a bit. Alright, so it rises up by 3, so it'll be over here, right? Where my pointer is. And then we go to then we run by 1. So we go over here. And that's where our next point is on our graph, right? So basically your point from first point to the next point, right? So from here you go 3 and then 1. So your slope will be 3x, right? And then so obviously your graph is -2. That's where your y-intercept is, where your graph crosses the y-intercept. And you guys might be, y-axis. And you guys might be wondering, what if there's 2 areas where it crosses the y-axis, right? Well, the thing is that in linear equations, you're never going to see that. Okay, that if it has 2 areas where it crosses the y-intercept, then that means that it's just not a linear equation. It would be some other type of equation, kind of like exponential, usually exponential, sometimes maybe quadratic, but yeah. So now let's go into negative slope. Now we just looked at a positive slope. Let's say we want to make it -3 over 1 x minus 2. We're going to keep everything else the same. We're only discovering, looking at the slope. So from here, what was the difference, right? Before, it was going up, right? From the left to right. So let me show you again. this is our graph when it was positive. It was going up from left to right. As we moved the x coordinates, if you look at my pointer, as we moved along the x-axis, greater and greater and greater, you can see the y-axis is going higher and higher and higher. That means it's a positive equation. So if you add negative, then it's the opposite. It flips over the y-axis. And then you can see as x is getting greater and greater and greater, the y is getting less and lesser and lesser. So that's how you know it's a negative slope. Now let's look at a zero slope, right? When basically our slope is 0. 0. What do you see here? Well, if you look at it closely, you notice that it's completely a straight line. A zero slope. And you might be wondering, if it's a straight line, then how do you know on which area it goes? What if it's a straight line over here, where my pointer is up on the y part of 3, where it intersects 3? Well, that's when you have to look at your y-intercept, right? Wherever your y-intercept shows, so as for example here, it's at -2, right? So that's where it intersects. So whichever area your y-intercept is, that's where the straight line goes through. So see 0x, right? That's the same thing as 0. So this is the same thing as the equation y equals -2. And this is the most common way you're going to be seeing it, right? And so if you wanted like an undefined slope, right? Then basically what you do, you just change your y into an x, and then it completely becomes a straight line. And you know why it's called undefined? Because this is not a function, right? If you were listening to the last video, right? Anything that's a function has to pass the vertical line test, right? Meaning that it can't, any line that you put through the graph, it can't cross the graph more than once. And here it grabs an infinite amount of times because it's a line, right? If you put a line right through the x is -2, that's literally not a function. So that's why it's called an undefined graph. And as I said earlier, this is the y-intercept, so if you want to change it into 6, then it basically intersect the x-axis. Now it's not the y-intercept anymore, it's known as the x-intercept. So that's some things you guys can look out for. And so, yeah, that's pretty much it, guys. Remember that it's m, so let me write this part again, mx plus b. Remember that m is a slope, and y is the y-intercept. No, the b is the y-intercept. And we went through zero slopes, undefined slopes. Remember, zero slopes are horizontal, and undefined slopes are vertical. And so now that we've gone through different types of graphs, now let's try to actually solve different types of, try to find the slope of different types of graphs. So there are a few ways you can find the slope, right? You can find the slope by find the slope. So you can find the slope. You can find the slope by either. Looking at the graph, looking at y equals mx plus b graph, and that's probably the easiest way because you can literally look for the m and mx plus b, and you would figure out the slope. Also, something else you can do is you can also look at 2 or more coordinates. You can just say 2 coordinates because that's all you need. Coordinates, and solve for slope. We'll be getting to that right after I finish this. And solve for slope. So yeah, guys, there are also so many other different ways, but these are probably the main 2 ways that you've seen it. Or you can also find the slope through looking at graph. There's so many different ways, but these are the main 3. So we already looked at the first one by just looking at the mx plus b. Let me change this part into line, or equation, I should say, equation, so we don't get mixed up. So number 1 and 3, you already went through those, looking at the equation and the graph. And now let's look at how to solve for it using 2 coordinates, right? So let's say that we had the 2 coordinates. Let's say we had 2, -3. Oops. We have 2, -3. So let's move it. Oops. Let's move this over here. So we had 2 coordinates, 2, -3, and we have another coordinate, 3, -18. Oops. 18. So from here, we have to use the formula. You guys should probably write this down. This is a formula to know. So slope is equal to y1. And you guys don't understand what this means yet. I'll tell you guys in a second. So the slope is y2 minus y1, parentheses, comma, over x2 minus x1. So basically, looking at two coordinates, that's all you need when trying to solve for the slope. Only two coordinates. y2 is the second coordinate. You don't have to really pick. You can just pick coordinate. That's the second one. So in this case, since it's going left to right, I'll just pick the second coordinate as the second one, 3, negative 18. So y2 is the y part of the second coordinate, so that'll be negative 18, minus y1, which is the y part of the first coordinate, so that'll be negative 3, over x2, which is the x part of the second coordinate. It's pretty simple, guys. It's pretty straightforward. And so let's solve for this certain equation. So we have y2, which is negative 18, like we just said, minus y1, which is negative 3, divided by x2, which is 3, minus x1, which is 2. Oops, let me keep parentheses around there so you guys don't get confused. Alright, so from here, negative 18 minus negative 3 is negative 15, divided by 1, so this would equal negative 15 as our slope. So our slope would be negative 15, and if you guys were interested in actually finding the y-intercept after this, you could look at just input. So we have our equation, right? We have y equals negative 15x, because we're putting the y equals mxb equation part. So if you guys look over here, the y equals mxb part, we're just basically doing that. So y equals negative 15, because that's our slope, m equals negative 15, x plus b, right? And how do we solve for b, right? We have three different variables, and we already have two variables given to us, actually. If you look at, just pick one of the coordinates above, either 2, negative 3, or 3, negative 18, you could actually input them into your equation to solve for b, right? Because we know that those two coordinates are part of our line, because that's what we use to derive our slope. So from here, let's use the first one. So we have negative 3 for the y is equal to negative 15 times 2 equals, or plus b. And this equals, so if you had negative 3 equals, let me put this in parentheses so you guys, so equals negative 3 is equal to negative 30 plus b. And so this equals b equals 27, because you just add 30 on both sides. So your final equation would be y equals negative 15x plus 27. So that's just a quick glimpse of how you can make your equation. I won't be going too in detail on the y-intercept part. It's pretty straightforward. If you guys don't really understand it, it's okay. Always make sure to let me know if you don't. I can make a separate video on that. But for now, let's go on to just keep at the slope part. So let me just get rid of all of this stuff. Alright. So now that we've gone through how to solve for the slope, right? I just went through one quick equation. You guys can go through multiple equations on your own to get more practice on them. But now that we've figured out that, right? Now let's look at like word problems, right? We want to know how to really solve actual quick questions, right? When you go to a test or a quiz, they're not going to ask you, okay, give me the slope from these two coordinates. They might, but if you want to really understand the topic, you need to go through word problems, really to understand if you know the concept or not. So let me just make a clean slate real quick, delete everything. Alright, so let's say we had the question, determine the value of y so that the line, let me move this up here so you guys, determine y so that the line that passes through negative 2 comma y and 6 comma 7 comma 6, negative 7 has a slope of 1/2. Alright, so this may look very hard to you in the beginning because you're like, oh my god, I don't know about the coordinates, but they give you the slope, right? So if you have the slope, you only need that to really solve for the other coordinate. So I'll let you guys know what I'm talking about. So we have y equals mx plus b, and we know the slope, so this is y equals 1/2 x plus b. We're not given the y-intercept, but we are given a point, right? And we're trying to solve for y, which is on the other point. So we do know that y is equal to oops. We do that y is equal to, actually, you know what? If we do say this, right, we need to make sure that we know what we're talking about, right? And just having the y equals 1/2 x plus b part and not knowing the y-intercept is not going to really help us. So if we have y equals 1/2 x plus b, then we can also make this into, okay, here. We can, here, let me move this over to the side so you guys can really understand it. So if I did y, we know y, right? If you just input the coordinate from the last one, we have 6 comma 7. So 7 is equal to 1/2 times 6 plus b. And from here you can just solve for b. And so b is equal to 3 because 7 minus 1/2 times 6, which is 3. So 7 minus 3 is b. So b equals 4. So b equals 4. And so now that we can make our full equation, which is y equals 1/2 x plus 4. And so from here we can really solve for y because we know x, which is negative 2. So y is equal to negative 2 times 1/2, which is negative 1 plus 4. And so this equals 3. So your final answer for this question, for which asks determine the value of y, so the line that passes through negative 2 comma y and 6 comma 7 has a slope of 1/2. What I quickly, just to really summarize what I did, I first inputted the slope, or the slope intercept form, y equals mx plus b, and then inputted all the things I know, such as the slope and the coordinate, to solve for the y-intercept. And then I relayed my full equation, which is y equals 1/2 x plus 4. And then I inputted the coordinate that we're trying to solve for, negative 2 comma y, into the equation, and I solved for the y part, which is 3. So let's go through one more equation before we end it off. And it's kind of like similar, but let me just get rid of all this stuff for you guys. And clear. Alright, so this question is actually also very similar. Has basically the same frame, so determine. I could actually just keep the, you know what, actually I'm going to do that. I'm just going to keep the frame and then change it up a bit. Alright, so we have determine the value of x, this time, x, so the line that passes through different, oops, I don't think you guys can see this. Alright, let's move this over here a little. Alright, determine the line that passes through negative 15 comma 9, right? Negative 15 comma 9 and x comma 7. X comma 7 has a slope of 4. So basically around the same question, we're just kind of flipping out which coordinate we're looking for and a different slope and coordinate values. So let's go through this. I'll give you guys actually a minute to really solve it on your own so you guys can see if you really understand it. Alright, now let's go through this question. So we have y equals mx plus b, mx plus b. From here, we know that we have the slope and the coordinate, so let's input that. 9 is equal to negative 15, or sorry, 4 times negative 15 plus b, right? And so from here, this is equal to 4 times negative 60, negative 15 is negative 60, and so add by 60 on both sides, so you'll get 69, so b equals 69. And so from here, all you have to do, guys, is, since you find b, all you have to do is just really input it into the equation and make your full equation. So we have y equals our slope, 4x plus 69. And so from here, you can just input our coordinate value that we need to figure out. So x we don't know, but we know y, which is 7. 7 equals 4x plus 69. So from here, we just solve for x. So x is equal to, so here, let me just put it into steps so you guys can really see what I'm doing. So we have 4x is equal to 7 minus 69, which is negative 62. Negative 62. And so negative 62 divided by 4 equals x. So x equals negative 62 divided by 4. And that's our answer. If you guys want, you can even simplify this further. This will be negative 31 over 2, which is also equal to negative 15.5. So yeah, guys, that's pretty much it. So we know that the x value that we're looking for is negative 15.5. So all you guys really need to know is, for a quick summary, is that this is what we learned today was slope-intercept form, and we just need to know how the formula works, y equals mx plus b. Also know the formula for finding the slope, y2 minus y1 over x2 minus x1. Make sure you write that stuff down. Those are very important. And then we went through different types of equations, positive slope equations, negative, zero equations, and undefined slope equations. Then we try to solve different questions about like finding the slope, determining different coordinates. So after this video, hopefully you guys really understand slope. So the next video we'll be going through lesson 2, which is going to be direct variation. And guys might not understand this now, but when we get to it, you'll probably understand it a little bit better. This is why I'm trying to make the video so you guys really understand it. And so yeah, guys, thank you guys for watching, and I'll see you guys in the next video.